Out in the vast, cold emptiness between the stars, something is heading our way. An object, designated 3I Atlas, has entered our solar system, and it's unlike anything we've ever seen. Astronomers watched in shock as it streaked toward Mars, its speed and composition rewriting the rulebook on cosmic visitors. This isn't just another comet. It carries a payload rich in carbon dioxide, nearly 8 times its water content, and it's closing in on Mars at a distance of just 30 million kilometers. But here's where it gets truly strange. At the exact same time, NASA's rovers on Mars are reporting potential biosignatures in the ancient riverbeds of Jezero crater. Is this a mind-bending cosmic coincidence? A natural delivery of exotic ices from a distant star system? Or could it be something engineered, something with intent? Today, we're diving deep into what 3I Atlas is really doing near Mars, and what happens next could rewrite the story of both the red planet and interstellar science. 3I Atlas is not your average comet. Its path through our solar system is hyperbolic, with an eccentricity greater than 1. That's a mathematical stamp proving it comes from far beyond our sun's gravitational reach. Astronomers confirmed this within hours of its discovery on July 1, 2025. The object's orbit calculations showed it would never return. Instead of looping around the sun like a planet or a typical comet, 3I Atlas is on a one-way journey, blazing through at nearly 68 kilometers per second. That's a staggering 150,000 miles per hour, far faster than any object born in our solar system. Its closest approach to Earth will be in December 2025, at a safe distance of about 269 million kilometers. But even from that far away, it's grabbing our attention for another reason: the glowing cloud or coma that surrounds its icy core. When sunlight heats a comet, frozen gases and dust erupt outward, forming this coma and sometimes a tail. Most comets are basically dirty snowballs, dominated by water vapor. But early spectral data from 3I Atlas shows a completely different recipe, one where carbon dioxide is far more abundant than water. This is not what scientists expect. The classic model, shaped by decades of observation, says water ice should be the main ingredient. Here, the balance is flipped on its head. This strange composition hints at an origin in a much colder, more distant environment than our own solar system can provide. As 3I Atlas races inward, it's forcing astronomers to revisit the very basics of comet chemistry. The combination of its incredible speed, unique trajectory, and unusual coma signals that this is a true interstellar visitor, carrying the secrets of another star system. Meanwhile, on Mars, another mystery is unfolding in the sediments of Jezero crater. Billions of years ago, a river carved its way across the Martian surface, fanning out into a broad delta. Here, layers of silt and clay settled, locking away traces of whatever life or chemistry once touched this ancient waterway. And among the patterns left behind, scientists have found something strange: rounded, mottled patches scattered across the delta, known as leopard spot textures. These features have sparked intense debate. Some researchers suggest they might be biosignatures, physical signs that life once flourished on Mars. Dr. Hiroshi Tanaka, a planetary chemist who has spent years studying Martian sediments, urges caution. He points out that on Earth, river deltas are natural vaults for organic molecules. Their fine-grained sediments protect fragile compounds from the harsh environment above. Mars, with its thin atmosphere and constant radiation, offers few places as promising for preserving ancient organics as Jezero's delta. But not every odd pattern is a sign of life. Dr. Tanaka's team has shown that similar spots can form through simple chemical reactions, mineral growth, or even the slow weathering of rocks over eons. The challenge from Mars science is separating what truly belongs to the planet from what might have arrived from space. A delta like Jezero's is a perfect trap, catching organics whether they formed in Martian lakes or drifted in on dust and ice from deep space. And with new claims about biosignatures circulating, the risk of confusion is growing. The timing of 3I Atlas as passed near Mars only sharpens the question. If a surge of new organics suddenly appears in the delta, is it a message from Mars's past, or a fresh delivery from the cosmos? The answers are buried in those layers, waiting for careful science to uncover them. A comet's chemistry is usually a fingerprint of its birthplace. For decades, astronomers have measured the balance of water vapor and carbon dioxide in comet comas, using these ratios to map where ices condensed billions of years ago. But with 3I Atlas, the numbers just don't fit any familiar pattern. The scientific community was buzzing as soon as the data hit the preprint servers. Some teams wondered if it was a calibration error. Earth's own atmosphere is thick with carbon dioxide, and subtracting its signature from a faint interstellar target is notoriously tricky. But follow-up spectra from the Keck Observatory and the Nordic Optical Telescope backed up the anomaly. Even the most conservative estimates put the ratio around 5-to-1, still far outside the norm. So what does this mean? Is this a window into how comets form in a different kind of molecular cloud? Or is it evidence of radical processing by cosmic radiation during its long, lonely journey between the stars? Adding to the puzzle, astronomers noticed a distinct green tint in the coma spectrum. This glow is linked to molecules like dicarbon and cyanide, compounds that can shine brightly when energized. In 3I Atlas, their intensity appears unusually high, possibly fueled by the same carbon dioxide-rich outgassing that makes it so unique. With each new observation, the chemical story of this interstellar traveler grows stranger. And now, we come to the climax. The countdown to October 3rd has become a frantic race against time. On that day, 3I Atlas will sweep past Mars at a distance of just 28 million kilometers. In cosmic terms, that's a hair's breadth, especially for an object that began its journey in another star system. But the moment of closest approach comes with a massive complication. Mars and 3I Atlas will be almost directly behind the Sun from our perspective here on Earth. For weeks surrounding the flyby, from late September through late October, the Sun's glare will swamp our line of sight, creating a total blackout window. Our most powerful observatory's Keck, the Very Large Telescope, even the James Webb Space Telescope will be blinded, unable to track the comet or the Martian sky. Even our radio links to Mars orbiters will become unreliable as solar noise drowns out their signals. The timing is excruciating. The flyby just geometry means that our best chance to observe any interaction between 3I Atlas and Mars falls squarely within this period of scientific darkness. The odds of an interstellar object passing this close to Mars during a solar conjunction are incredibly slim, roughly 1 in 100 per year. So what happens now? Is this a natural event that we're just unlucky enough to miss? Or is there something more to this perfectly timed flyby hidden from our view? The fate of this mystery now rests with the instruments already at Mars. They are our only eyes and ears. What they detect in the coming weeks could change everything we thought we knew about life in the universe. Hey everyone, welcome back to the channel. Today, we're diving into a story that feels straight out of science fiction. Imagine this. The most fascinating interstellar visitor to our solar system in decades is about to fly past Mars, the one planet where we're actively hunting for signs of life. But here's the catch: Earth is on the opposite side of the Sun, in a cosmic blackout called solar conjunction. It's like the universe is daring us to solve a mystery while tying our hands behind our backs. As this celestial drama unfolds, our main observatories on Earth are forced to look away. So, who's left to watch the show? Attention has shifted to our robotic eyes in orbit around Mars. These orbiters, running on pre-programmed instructions, are our only hope of capturing data from Comet 3I Atlas as it zips by. The pressure is immense. Every observation window, every minute and every byte of data could be the key to unlocking this comet's secrets. The clock is ticking and the universe waits for no one. Our last line of defense against this cosmic enigma are the orbiters circling the red planet. Specifically, the European Space Agency's Mars Express and the ExoMars Trace Gas Orbiter have been repurposed for this high-stakes mission. Their new task? Capture any evidence they can before the opportunity vanishes forever. Dr. Colin Frank Wilson, a project scientist for Mars Express, called this a rare scientific gamble, the kind of opportunity that might not happen again this decade. It's a long shot, but one they have to take. Let's look at the tools they're using. The high-resolution stereo camera, or HRSC, on Mars Express is a beast. It's designed to map the Martian surface in incredible detail. But from 28 million kilometers away, even this powerful camera will see Comet 3I Atlas as just a faint, tiny dot. The projected resolution is so low that the comet's core and its surrounding cloud of gas, the coma, will blur into a single pixel. The only way we'd see more is if the comet has a sudden, massive outburst, becoming unexpectedly bright. The odds are slim, but they're not zero. Then there's the Nomad spectrometer on the Trace Gas Orbiter. This instrument takes a completely different approach. It is tuned to sniff out specific gases like carbon dioxide and water vapor, the very compounds that make 3I Atlas so unusual. In theory, if the comet releases a strong enough plume of gas as it passes, NOMAD could detect its chemical fingerprint. We know this instrument is sensitive. It can detect gases in the Martian atmosphere in parts per billion. But trying to catch a signal from a faint, distant comet is pushing its capabilities to the absolute limit. It's a true challenge. Both orbiters are facing some serious operational hurdles. During solar conjunction, communicating with Earth is difficult if not impossible. The instruments have to operate autonomously, following scripts that were programmed weeks in advance. There's no room for last-minute adjustments if something unexpected happens. Plus, any data they collect will be stored on board for weeks until the blackout ends. If the memory fills up before they can send it back, that precious information could be lost forever. It's a high-wire act with no safety net. Adding to the difficulty, the comet is incredibly faint, predicted to be around magnitude 17 or 18, which pushes the detectors on these orbiters to their very limits. The best-case scenario for most of the cameras is capturing a single point of light. Other instruments might not see anything more than the faintest glow, if that. Dr. Wilson and his team have had intense debates about how to best use this precious observation time. They know the chances are low. Unless the comet puts on a spectacular and unexpected show, they'll likely end up with what are called upper limits, basically data that says, we looked for this and we didn't see it. But even that is valuable. These constraints help narrow down what's possible. And if, against all odds, they do detect a spike in carbon dioxide or a spectral line that shouldn't be there, it would trigger a scientific frenzy. Every frame, every bit of data would be re-examined. The hunt is on for something truly weird, an abrupt change in its gas output, an exotic molecule, or a dust grain, unlike anything we've ever seen. For now, all they can do is watch, record, and hope they get lucky. The universe has given them a unique assignment, and they're racing to meet it. So, what could this comet actually be? The speculation has broken down into three main theories. The first and most straightforward is that this is simply a rare but natural event. Based on our models, an interstellar object like this should pass this close to Mars roughly once every 50 to 200 years. So while it's a long shot for it to happen right now, it's not impossible. Most astronomers see this as a statistical coincidence, a reminder that randomness can sometimes create patterns that we're tempted to assign meaning to. The second possibility sounds a lot more like science fiction. It taps into old ideas about terraforming. Could 3I Atlas be a delivery system intentionally steered towards Mars? The comet's chemistry is definitely intriguing. It has a strange 8-to-1 ratio of carbon dioxide to water, a green glow that hints at unusual energy. And its path takes it right past Mars just as we're finding potential biosignatures there. For this to be true, we do need to see evidence of guidance, a non-gravitational change in its path, or some kind of artificial fingerprint. So far, there's no sign of that. Its orbit looks natural, and it's radio silent. Still, the orbiters are watching for anything odd. The third idea is panspermia, the theory that life, or its building blocks, can travel between star systems by hitching a ride on objects like comets. If the cloud around 3I Atlas contains complex organic molecules, it could lend support to this theory, but proving it is incredibly difficult. Scientists will be looking for specific isotopic fingerprints ratios of elements that do, and match anything we know from our own solar system. Only then could we start to rule out coincidence and consider a truly alien origin. Each of these scenarios has a very high bar for evidence. For now, the odds strongly favor nature, but the search for something stranger is what makes this so exciting. Naturally, with a mystery like this, rumors have been flying. You may have seen memes about cosmic clocks or seen claims that this is an engineered event. But in science, extraordinary claims require extraordinary evidence. The high carbon dioxide content and its timing are still puzzles, but nothing we've seen so far supports the idea of artificial intervention. What this event is truly doing is deepening our understanding of interstellar chemistry and the incredible challenges of searching for life beyond Earth. Ultimately, the flyby of 3I Atlas is a rare, natural experiment. It's a test of our technology, our scientific skepticism, and our ability to tell a meaningful signal apart from cosmic noise. Whatever we find or don't find, it's a powerful reminder of the vast, mysterious universe we're a part of. Thanks for joining me on this cosmic journey today. What do you think is going on with this mysterious comet? Let me know your theories in the comments below. And if you enjoyed this video, don't forget to hit that like button and subscribe for more deep dives into the mysteries of space. See you next time.